Hi, I'm Toby Wakefield-Carl, and so we're going to be looking at an example problem from the 2019 FRQ as the second problem on there. Yeah, so just going into it, we want to first make sure we identify the type of the problem it is so it can help us formulate some strategies. So obviously looking at, we have the chart right here. So clearly this is a chart problem based off of we see the chart. So typically, we'll be asked to approximate instantaneous rates using the average rate, since we don't have a formula. So yeah, since there's no equation, then we'll have to use the average rate formulas to just approximate the instantaneous rates. And then also we might be asked to find the area using either trapezoids or rectangles, so Riemann sums or using the trapezoids. All right, so we'll just look at the first part of this problem. Here we see justify why there must be at least one time where the acceleration equals 0 meters per hour. So here we're going to try, and what I did was try to see what can we use to really justify that. And so one way is we see acceleration there, and we know that based off of this chart, this is the meters per hour. So this is a velocity chart. And so we're looking at trying to find where the acceleration equals 0. So since the acceleration is the derivative of the velocity function, we just want to find a place where the derivative equals 0. And so using the mean value theorem listed right here, so there would exist at least one point between A and B where the derivative will equal whatever this side equals. And so yeah, just using that. And one thing we want to make sure we clarify is that to use the mean value theorem, we have to make sure we clarify that since it gives us that it's a differentiable function, so that also means it's continuous throughout the entire domain of the function that is given. So we can use the MVT here, and we just plug it into this equation here, f of b minus f of a over b minus a, and then that will come out to equal 0. So then our answer, we can say, therefore, using the MVT, we can show that the acceleration equals 0, meaning there is at least one point between 0.3 and 2.8 where the acceleration equals 0 meters per hour. All right, moving on to part B of the question. You see here, this is another way. One of the things that we've been asked to use, finding the area to, so right here, finding the value of this, which is the area, using the trapezoidal sum. So it gives us the 3 subintervals to use. So when remembering the trapezoidal area, we just have to multiply the width of each section, and then multiply it by the heights that we have here listed in the function. So we just plug it in. So we have the width of each one. We plug in the value f of 0 plus f of where the next section ends, and then we divide that by 2, and so we add up those all together, and then we come out to 40.75, and that'll be the answer for that equation. So yeah, so this is how to approach this problem, and just to identify it and go through different methods, and just remembering how to calculate each part of the question.